In the previous class, we have discussed bar-shaped and U-shaped electromagnet. On the basis of that discussion, let's do this question. In this question, we have a soft iron U-shaped frame over which a wire is coiled like so, okay, on both the arms, and a current I is flowing through the wire. Okay. Now find the polarities developed at the ends A and B. Okay. What are the polarities developed at the ends of this frame? Okay. Since we know that the polarity is decided by the direction of current flowing in the coil. So we have two coils, coil 1 and coil 2, okay, on both the arms. In the second coil, the direction of current is like so. Okay. The arrowheads showing the direction of current in the second coil. And if you see from this side, then the current is anti-clockwise in this coil. Okay. And since we know that a current carrying loop produces magnetic field, and that magnetic field is given by right hand rule. Okay. And saying that when you curl your finger in the direction of current, okay, circular current produces straight magnetic field. So when you curl your finger in the direction of current, then thumb will give you the direction of magnetic field. So magnetic field at this end is outwards. Okay. So the magnetic field is like so. Okay. Now come to this end. In this coil, in the first coil, the current is like so. Okay. The direction of current is given by the arrowhead in the first coil, and as seen from this end, the current is clockwise. Okay. The current is clockwise in this coil, and from the right hand rule, when you curl your finger, right hand finger, in the direction of current, then thumb will give you the direction of magnetic field. So magnetic field is inward, okay, into the frame. So the magnetic field is like so. As we know that the end where the magnetic field lines are entered is known as south pole, and the end where the magnetic field lines are emerged is known as north pole. So this pole, this end becomes north and this end becomes south. Okay, because at this end the magnetic field lines are emerging, and at this end the magnetic field lines are sinking or entering. And inside the frame, soft iron frame, the magnetic field lines are running like this. Okay. Okay. So the magnetic field lines are parallel and equidistant inside the frame, and this type of magnetic field is uniform magnetic field. Okay. Second question is, what happened when the direction of current is reversed? Okay. The answer is, when the direction of current is reversed, then the polarity gets reversed. Why? Because in that case, the current in this coil, in the first coil, becomes anti-clockwise, and in this coil the direction of current becomes clockwise. Okay, and clockwise current produces south pole, anti-clockwise current produces north pole. Okay, so when the direction of current is reversed, the polarity gets changed. Okay, now the question is, how we can increase the strength of the magnetic field produced by the current. So the magnetic field strength can be increased either by increasing the current or by increasing the number of turns, okay, in the coils, because we know that the magnetic field strength B is directly proportional to the current. When we increase the current, the magnetic field strength also increases. And second, the magnetic field strength is directly proportional to the number of turns in the coil. When you increase the number of turns in the coil, then the magnetic field strength also increases. Okay, so this is the solution of this question. Please note it down.